Can everyone hear me okay? Testing audio, testing, testing, testing. Do I sound all right? Sweet. Okay, what about... Yeah, no, the level is a little low. I need to... Yes, it is being recorded, by the way. How's the font looking? Is that big enough for you guys? Can you see that okay? Awesome. Okay, yeah, there's about a 10-second delay between me doing stuff on the screen and talking and then the chat, so keep that in mind. So it'll drive you nuts for a little bit until you get used to it. All right. Let's go ahead and get started. It is 101. All right. So everything seems to be good. We'll just kick it off. So this is infrastructure testing with Pester. I am Adam Bertram, and I am also known as Adam the Automator. All right. A little bit about me. I'm a training course author, do a lot of stuff with Pluralsight, one for Udemy, do a whole lot of PowerShell stuff, DevOps training in the community, do a whole ton of freelance writing, articles, a book, which you'll see a little bit, consultant, do a lot of blogging, blah, 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 and I'm on Twitter a lot at AD Bertram, so feel free to follow me if you want, or reach out whenever you have any future questions or anything like that. Okay, before we go into the what to expect, questions. I put it in the comments here, but if you didn't see that, if you could just, as you have questions as we go along, just put them in the live chat. I'll try to answer them as I can, if I don't lose my focus too much. If not, I will make sure to come back and answer all those later, and then the ones that we don't get to, I can either follow up on Twitter or email or whatever. And the talk is going to last about maybe around an hour or so, maybe hour 10, something like that. So that's what you're in for. All right, so for the content-wise, what to expect. First of all, it's not a talk on Pester itself. It's not a how-to, because what I've found is there's a lot of stuff out there for Pester how-tos, which is the Pester book that we wrote, and there's a lot of other courses and articles and things like that with Pester. So this isn't going to be about Pester itself. So I expect you to know somewhat, what's a describe block, what's an it block, that sort of thing. Next, it's going to be about infrastructure test thinking and mentality. And also, it's going to be about implementing designs with code. So what do I mean by that? This is kind of a soft topic. I'm not really going to get extremely detailed and technical with this. I'm going to obviously go through a lot of code and some technical details, but I'm going to try to stress the fact that with an infrastructure test, you'll see in a minute here that an infrastructure test by itself is pretty simple. It's all about just reading something, making sure compare it with a known state. So it's really easy to implement. The hard part is figuring out how to implement this mentality or this methodology inside of your infrastructure test. And for implementing designs with code, you have, whenever you build a new infrastructure, a new environment, you have these certain design patterns that you follow. You have you need a VM that needs this much storage, this much RAM, that sort of thing. You have these designs ahead of time. This is what the course I'm going to focus on, is creating these designs with code and then how to implement that with Pester. If you don't know a lot about Pester already, here's a book that I highly recommend. Where did this come from? I don't know. This just got in the slide deck somewhere. But this Pester book, did a lot of writing with this. This is the best. I don't like tooting my own horn, but this is the most comprehensive overview of what Pester can do, all the way from the basics to anywhere from design patterns and all kinds of stuff. So if you're not familiar with Pester itself, go out, pick up this book. There's a free sample if you want, and there's even a 30-day no questions asked money back refund, so you don't have to worry about getting something crappy. All right, so what is infrastructure testing really? So in essence, it's really just three different things. First, we define an expected environmental state. What does that mean? Well, that means you create. I'm going to go back to the example of an Active Directory user because that's the most common. Let's say you create an Active Directory user and you create it with new AD user and you specify first name, last name, department. Maybe you put it in a specific OU, that sort of thing. All these different attributes. That's all combines to provide an environmental state. A VM could have a state. It could be on a specific host. It could have a specific amount of memory. It could be attached to a specific AD, or a VHD, that sort of thing. Next, after we define what we want, that expected state, then we actually run the code to retrieve the actual state. So this is the point to where we run, instead of new AD user, we run get AD user. At the first step, we do a lot of new sets, adds, the create, update, and delete commands. So we do change a lot of things. In this phase, we do a lot of get commands, get AD user, get VM, get child item, a lot of getting. We gather up all that stuff. Once we do that, we just compare the two. We compare the actual versus what we were expecting it to. And then finally, this is not unit testing. I cover unit testing extensively in the Pester book. This is not going to be about any form of unit testing because unit testing is a completely different animal. It's probably harder to understand, which is why we go through a lot in the Pester book. But this is not unit testing. This is infrastructure testing, which if you've heard other terms, maybe integration testing, acceptance testing, it's kind of fuzzy. Okay, so the benefits of infrastructure testing. First off, you understand your code's entire life cycle. This is just testing in general because with this, when you have to build tests, you have to truly understand everything that your code is doing. You can't just spend some time on a piece of code and just kind of do whatever, get all distracted and run somewhere else and come back and then forget where you were and then run the command or the script that's a 500-line thing and, it doesn't have any errors. Well, sure, it doesn't have any errors, but how do you know that it actually did what you wanted it to do? To define that, we have to go in and manually look at your code and figure out, okay, you have to explicitly define what you want. You define the definition of working here. So with code can be extremely complex. There can be huge applications and things that do all kinds of things. And it's really hard to put a 1 or a 0, a working or a non-working on it. This is what infrastructure test does for you. So, for example, let's say that, going back to that AD user example, you create a new AD user in a script. You create a home folder in a script for the AD user. You create an Exchange mailbox for that user. That's 3 different tasks that you do in that script. Let's say you run it, doesn't return an error, but maybe you had your error action preferences set to silently continue or something, and it's just throwing exceptions out the door. You're not even seeing them, or really maybe you forgot to even put something in there that you intended to. If you write your test is like the litmus test, I guess, of if you define working or non-working. And next, it increases your trust. This goes for unit testing, infrastructure testing, testing in general, that this is the number one benefit that I have found from testing in general, because before I did infrastructure testing and unit testing for that example, I didn't really trust my code, and I'm sure you may not either. Maybe you have this janky script that's huge that no one wants to touch because you may break it. You need to make a change. You don't trust it because there's no testing behind it. If you have a test suite behind it that tests everything that it's supposed to do, then you're much more able or you're much more willing to go in and change stuff. And then finally, in our a DevOps example here, reliable deployments. Let's say that you're using it for a DSC. We'll go into a lot into a DSC configuration in demos here in a minute, but whenever you deploy infrastructure as code or configuration as code, you take code to build infrastructure. It really increases those deployments, especially if you have the automated test and a build pipeline. You can just easily automate all these things, which I'll show you here in a minute in the demos on how all that works. All right, so infrastructure testing is a tool for many purposes. Now, there's two different aspects of this. So the first one is just testing general changes, and what I mean by that is, for example, since I told you about the first three, the three things, you define the state, get the state, and you compare the two. With general changes, Joe from HR or Susie from accounting or anybody can make a change somewhere manually, go into ADUC and create an AD user, or go into regedit and change a registry key, whatever. That is just the change that's made. An infrastructure test can be written to just verify that specific change. It doesn't necessarily have to be the result of code, but what you can see that we're going to be focusing on here is code, infrastructure as code, especially in DSC. We're doing that because if you're testing just general changes with your infrastructure test, you're kind of getting into the monitoring realm. So there's a kind of a gray line between infrastructure test and monitoring. With monitoring, you ping something if it's up. This user can authenticate just fine. And it does that in a recurring fashion. Infrastructure tests and monitoring are different because monitoring is essentially doing those tests at a certain interval all the time. Monitoring is really never a result of code. So if you write a DSC configuration that does a whole lot of stuff, you're not going to, maybe a piece of that is monitoring after it all gets deployed in production and all that good stuff, but you're never going to kick off a monitor. Let's say you tweak something in your DSC configuration, and then you automatically have your monitoring application, whatever it is, hit it and make sure it's right. It's not really meant for that. Monitoring is more ongoing, recurring. Infrastructure testing are really meant to run right after you make the change, because it not only tests your infrastructure, in testing that your infrastructure is in the right configuration, it's also testing your code in a roundabout way, because unit testing tests your code, infrastructure testing tests the result of your code. All right, just to go over a real world scenario here. This is something that I've recently went to that's fresh on my mind that I did at work. So I'm an automation engineer, and it's my job to take the developers, what they have in their app, make it all automagical, make it all work just dandy, and then provide them with a tool that they can just spit it out whenever they want. Here's an example of this. This one was in Azure. So as part of this, there was all kinds of objects that we had to take into account. A gateway, APIs, a SQL database with all kinds of different configurations in it, SQL file rows, web app service plan, all these different components would what make up a one single application. So all of this was boiled down just a 1 and a 0. Is this application working or is it not working? In order to give a check mark to is it working or not, there's no way that we could possibly go in and manually check all these to make sure it's working. Well, I guess we could, but we'd probably be crazy. So this is the example. And before I put testing in quotes here, because this is kind of how it was before. This may sound familiar to you if you're in a DevOps or automation role. So the developer would come to my manager and he says, I have got this thing. I've got this app that we've all created. We've got some run books. We've got some documentation for it. Can your team do this and automate this stuff for us? And so we can just deploy this to production. My manager would say, okay, sure, Adam, go do that. I would go do this, and I would take all those requirements and then create code from it. So I would take, I would go from, GUI steps of Word documents and click here, boil all that down to code. And then in this instance, since it was in Azure, I would go through and check the portal, the Azure portal, and decide, okay, yeah, when I run this code, check the portal, yeah, that looks good. That object is there. That's there, that's there. I did this hundreds of times for all these different configuration items. I would then say, oh, okay, yeah, that looks good. I'm confident. I'm going to check off that. Then I send it over to the developer, and I say, okay, this looks good. Can you verify that all of this is being, built as you would expect it to? And he usually would go, okay, yeah, that looks good, looks good, looks good. Oh, you forgot that one thing. That's what always happens. There's always that one thing. Maybe the developer forgot to include something in the requirements. No, that never happens. But or I forgot to, I missed something in here. We're humans. We make mistakes all the time. And when we make these mistakes, we're just looping this all around. I don't know how many times this loop would go on. And then finally, we would go through, waste everybody's time, and eventually figure out, then the developer finally says, yes, when I run this code, this is exactly what I want. And then we move on. There's a lot better way to do it. And this is the better way. This is testing, infrastructure testing, not in quotes. This is an example, a real life example of something that I built here recently that tests all these different things. You notice there that we have 132 tests for this. This is just infrastructure tests. This isn't even the unit test for this. So this can give you an example of the breadth of scope. There's a lot of things in here we could probably do some other testing around, but for the most part, this is probably 95% complete for 132 tests for all of those objects that those components that I shared with you. So this is broken down by context in a Pester test. So whenever I create infrastructure tests, context really kind of mean a different meaning for me, because with unit test, there's some mock scoping and things like that, some functionality that's in there. But when you do infrastructure tests, contexts are really just a good way to break out specific components. So I have one describe block. I could have chosen a few different describe blocks for this, but in this instance, I had one describe block and a lot of different context blocks here. And then I just broken out, like I took the requirements. Whenever the documentation came to me, I would take those requirements, boil them down not just to code, but to the actual tests themselves. So I would put in there, BDT02, which is the environment that I was working with here, lab, has the expected title, has a approval required state, subscription limit, the state, blah, blah, blah. I would define all those expected values up front, and then once I had that kind of framework built out, I kind of do a TDD hybrid sort of approach. Then I would actually build the code to make these pass, and then it would run through, and then if all of them failed, we had 0 failed, then we know that is working, or if any of them failed, that's non-working. It's a non-starter. All right. Last slide here, I think. Yep, last slide. So the reason testing is awesome and the way I really just get passionate about it and just geek out on it was because it's 3 things: repeatable, automatable, and reliable. Because testing is repeatable. You can just hit the button as many times as you want. There's a Uncle Bob. I don't know if you're familiar with Uncle Bob. He's a software development guy. He's big in the software dev space. And he has this talk about the big red button with testing. This is one thing that, this is actually the reason why I sort of got this big red button here. So listen to this.
That was easy.
That's the Staples easy button, if you didn't know. So testing is kind of like this. I can just hit the thing,
That was easy.
run my tests, write my code, run my test by hitting the button.
Was easy.
And then once the tests are done, I can just know green or red, easy, 1 or 0. It's automatable too, because it's all in code. All I have to do is just invoke a script, and it's good. And finally, it's reliable. You deploy reliable code. You deploy code that's working 100% of the time. There's no guesswork at all. All right, so first demo here, we're just going to go through some very, very basics of what we're going to do. We're going to, in the next couple demos, we're going to build one single project. So in this instance, this is kind of a small little piece of that whole project we're going to go through. So we're going to do an AD, Active Directory user. We're going to create an AD user somehow. I don't care. It could be, your coworker doing it. Could be you doing it with ADUC, with new AD user in PowerShell. I don't care. Then we're going to create the get AD user code. Just we're going to have to grab it somehow. And then we're just going to run the code to compare it with Pester. All right, so let's jump on over here to the demo. All right. So first off, let me bring this down a little bit. So the first step, which is obvious, what you're going to do is you're going to have the code, whether it be a DSC configuration, whether it be a PowerShell script, or anything, Python, whatever, it doesn't matter. There's just some outside process creates this AD user. So notice here that I'm just creating this one single AD user with new AD user. So I will go ahead and just copy this in, and I've already created the AD user, so I'm not actually going to do it. I know it's already there. But so we have the AD user created. We've ran the code to actually make it happen. Next, what we need to define what changes did we intend to make to the environment. Now here's a quick tip for you. This is a tip that I've used a lot whenever I've done my testing, both infrastructure, integration, acceptance, what have you, and unit testing. A good example of what to test is by looking at parameter values in your functions. So in this instance, notice that I ran new AD user, and I've given it a given name of Joe, a surname of Jones, a title of manager, no, I forgot the R, manager of accounting, has a specific account name, it's enabled, it has specific initials, and it's in an appropriate path. So to get those values to test with, you can easily just look at the various parameter values of the functions that you're actually running or the DSC resource attributes that you're invoking to build those tests. So it's a really good way to do this. And in order to do this, you need to split your configuration data, which we'll show in a minute for DSC, to away from your actual functional code. So notice in this instance, I'm using splatting. When I use splatting, I can define a hash table, define all the different parameters that I have for this particular command, and then I can just pass it to the command with an ampersand and then pass the hash table. If we have all of these built split out like this, whether this be in the same file or the same file here, whether it be in a different file, which we show with the DSC for the configuration data, that it doesn't matter as long as it's split from here. Because the reason why it's important to split all that data, the actual static data from your functional code, is because of this here. So here I have a single describe block just called AD user creation. And if you have seen the Pester book, I talk a lot about the arrange, act, and assert methodology, to where in tests, a really popular way to run tests is to do arrange and act, which means arrange means get all the code appropriate ahead of time to actually find the expected state, or to find the actual state that you're in. Act means actually run the code. So in this instance, we're just doing one step. We're just running get AD user to grab it from the domain. And then once we do that, we run the assertion phase, which the assertion phase are the should assertions here. So these are should assertions. And then notice here we have each of the it blocks, and I've just basically broken down, converted essentially the parameters for this function to should have expected title, should be enabled. You know, these keywords may seem should seem familiar here because they are the same parameter values that we or parameter names that we specify: title, enabled, middle initial, first name, last name. It's a really easy way to do it. And notice that here, I'm not calling get AD user over and over and over again. I just need to call it once. This is the act phase, the arrange and act. So I grab all that, the actual state, and then I can just reference those values from the variable that I have here. So since I already have it up here, I can just do AD user title should be, and instead of actually putting the title statically in here, since I've broken it out already, and I know for a fact that this is the value that I provided to it, it's a much more reliable way than saying, let's see what the title is. So let's say that, okay, up here I have manage of accounting. Well, I didn't notice that I made that goof, and down here maybe I do manager. I actually did it right, manager of accounting. That may sound right because, well, yeah, I put it manager of accounting up here again. This is going to fail because I did this up here. This is, in this instance, this is actually a good thing because I made the mistake up here. So what's important is you define, make sure all these are correct, all your parameter values, whether that be in a hash table, in a in a CMDB somewhere or XML, wherever, just wherever you're grabbing them from. You can just reuse that stuff over and over again, and that can be the one single source of truth that you have. So you don't have to constantly have to statically put things in over and over again. And really, I just kind of repeated myself on a lot of these. Should be the department. Here's one should be like, because we on the path parameter here, we don't have the fully distinguished name. I just did a like in here. So and then whenever I get all that done, I can then just run my describe block or with copy it in here or just run it with invoke Pester. And then it should say, should have all these, should be green. Yay, good to go. So that's kind of what we're going to be doing in a nutshell here, just on a lot bigger scale in a minute. All right, so that's kind of the whole process that we're going to be running through. All right, so let's go over here to demo 2. All right, so from now on, the demos are going to be cumulative. I can't remember from school. Cumulative, I think, because they're all going to be part of, we're going to build upon one single project. So I want you to realize whenever we start these demos, the code itself that I'm going to be showing you is not going to work individual demos until we get down to, let's see here, until we get down to demo 7 to where I'll merge everything together because the code base is fairly large with this. I wanted to kind of split it out to help you understand kind of what's going on. All right, so the project we're going to be building the infrastructure test for is a DSC project. And as part of this DSC project, let's see here. This DSC project provisions a new domain. We're going to build the DSC configuration of whatever we want. We're going to apply the DSC configuration. This is what's going to happen in our overall big project. We're going to test the DSC configuration with our infrastructure test, and then optionally, which we're not going to do here because it takes way too long to actually bring up VMs and do everything, you can actually remove everything that you did in the process. So let's go over here, and we'll just quickly go over this, and we'll show you what this does here. So I'm in the configuration data PSD1 file. So as part of a DSC project, I highly stress that you always do this. You always put your configuration data in a different file because it just splits it out and it makes things so much easier for testing. So in this instance, I just have a single node here called testlab.dc. And notice that I've built it out to where in the all nodes, I have node specific features. So this is a DSC tip for you if you're wondering how to best structure all this data. I have all nodes, and then I have all node settings here, and then I have each node that I want. So in this instance, I have testlab.dc purpose. That's a node specific thing, and the Windows features that are attached to this particular node. And then inside of the non-node data, I could use another name if I wanted to, but here I'm using non-node data, and this is like the general stuff that I'm going to need. All these static values are here inside of non-node data, the domain name, safe mode administrative password. Don't ever do that. But 80 groups, all the 80 groups, OUs, and then 80 users. If I have an object that I'm working with, like an 80 user that's more than just a string, I will create an array from it and then create hash tables that specify all the different attributes that I want to specify for it. So I'm doing a lot of that sort of thing. So that is the configuration data that our DSC configuration script is going to run. And then next for the DSC configuration script here, for all nodes, I'm looping through all nodes. And in this instance, I'm just grabbing all the nodes that have a purpose of domain controller. Here, I'm doing some LCM configuration here, just continuing if it needs a reboot, since it's going to promote it to DC. And here's to where I don't have to replicate a bunch of x80 groups and x80 users and stuff. I because I defined these all in an array, I can just, in my DSC configuration, I can just define configuration data, non-known data, AD groups, and do a for each loop and just loop through all these and pass in the group name. And if this is all in common, I want to make sure they're all present, I can just put this directly in here. And I do the same thing with OU. So I'm just grabbing all of those OUs from the configuration data, passing them directly to DSC, and I'm doing my thing. Same thing for AD users. So no real rocket science here on what I'm doing for the DSC configuration. All right, so once I run the DSC configuration itself, it's going to run through, do its DSC thing like you would normally expect it to. I've already ran it to save time, but it just went all through my machine and making sure everything is good, worked great. All right, so that's kind of the first part. You build the DSC configuration. Next is defining expected behavior. Now, what I mean by this is the part to where you define what you mean by expected, because this is what I talked about before, defining that configuration data outside of your functional code. I cannot stress this enough. Don't tightly integrate, don't tightly couple your configuration data with your actual functional code, because whenever you go to testing, and everyone's testing, right? All right, I'm going to pretend like everyone said yes. If everyone is testing, you're going to have to pull that stuff out anyway, or you're going to have to replicate all those values in your test code, which you're human and you make mistakes just like everyone does. And, it's just not the way to go. And finally, you just reuse it for your test. I've talked about that. I'll probably beat the dead horse on that one. So here's how we're doing. We're reusing that data to build the expected data. So because I have all that data built out of configuration data here from my DSC configuration, I've expected attributes. So now notice that it's not configuration data for DSC, it's expected attributes for my test. It's the same exact data in configuration data. I'm just using import PowerShell data file to convert the script to a hash table. Once I do that, then I can just manipulate it any way I really want. So here I'm saying, what's my expected domain controller name? I can grab this out. Instead of saying test lab DC or whatever it is here, I'm dynamically creating the code to bring this out. This is a lot longer. Obviously, this piece right here is a lot longer than just saying test lab DC, but it's dynamic. As soon as your configuration data changes, not only does your DSC configuration change, but your Pester test will change as well because it's referencing this. And then finally, I just keep going down and through here. This is just a snippet of the main piece that we're going to be looking with here. So I just have expected groups, users, OUs, that sort of thing. All right. Next is dependencies. This is by far and away the biggest pain in the butt. The biggest pain in the butt when you deal with infrastructure, when you deal with the environment. This is why I love unit tests so much, because unit tests don't touch the environment whatsoever. You just mock everything out and it all goes hunky-dory and it's great. It runs real quick. Run through your code, run through your test. With an infrastructure test, you have, it touches the environment, and the environment is, let's just say, less than optimal sometimes. So what I mean by that is if your environment is up and running, great, it's perfect. So if you have your VM running and you're doing a test for a domain controller on a VM, perfect, running great, everything is working fine. However, that stuff, the dependencies must be accounted for because you can't really rely on that. So for example, with a directory, with a, let's say with a domain controller, you write that DSC configuration script like we did earlier. That DSC configuration assumes a lot. So you may think, well, I put everything in the DSC configuration. I have I say I want the Windows feature. I say I want the Active Directory users, the computers, all this stuff in my DSC configuration. Well, you are assuming quite a bit in there. You're assuming that you have a network connection that will actually deliver the DSC configuration. You have a virtual machine, or you have a physical server out somewhere that'll actually do it. You're assuming that, DSC is working right on the machine. You're assuming that, PowerShell remoting is available. You're assuming there's a lot that happens on the stack to actually make that happen. When you run an infrastructure test, you need to just test exactly what you want. So you want to make sure if you're running a test for I don't know, an AD user, I'm going back to that example again, you want to make sure that all those dependencies are taken care of. Now, you can get all crazy and OCD with this, but for an AD user, I always make sure to test, is the machine that I expected, the domain controller that I'm hitting up, is the VM exist? Can I hit it? A lot of those different dependencies, and you need to be able to define the failure action. So what happens when one of those dependencies fails? All right, so go over to dependencies here. Let's clear this out of here. Okay, so this is a component, again, a smaller piece of our project that we're going to be building on. So we're continually building on it here. So the first part here, simple stuff just to make the test happen, just to connect to my Hyper-V server. I have a VM running on a local Hyper-V machine here that I'm going to be connecting to that I assume is up and working. And this, to deal with these dependencies, we do 3 different actions here. First, we need to make sure before our test run, we need to make sure that the dependency is there. So make sure that it's true or false, working or non-working. If it's not there, we have 2 options. We can either stop the test completely, or we can implement code to satisfy that dependency. So I mean by there is, let's say that you have a VM that's, that you're running a domain controller that you expect it to be there. If it's not there, what do you do? Well, you can either bomb out, say, and with an accurate error message saying this VM is not here, versus some crazy RPC unavailable error in your test, which you have no idea what you actually tested. Or since we have DSC in PowerShell, we can actually create some infrastructure code to actually make it happen. So we can bring up the VM on the fly. We can even create the VM if we want. We can use, this is a good thing that Chef's Test Kitchen does. It allows you to bring up these VMs at will in the cloud or on-prem, wherever you want, and in order to satisfy all those conditions. And then next, if all the dependencies had to be satisfied, so if you did anything, like you brought up a VM or you changed anything in the environment just during your testing, make it like it was before. Clean up your stuff. Blow away the VM. Stop the VM if it was stopped already. You just clean up after yourself. That way your tests are non-destructive. They don't actually change anything. So here is how I try to implement these tests. And again, I use hash tables a lot here in the examples because they're easy to demo, and it's a really good way to structure this. So this doesn't have to be a hash table. This could be in a database. A CMDB could be anywhere, as long as you have these defined in some kind of structured, standardized way. So how I deal with these dependencies is each key in here, I have one single array here, and I just call it dependencies. And it's ordered for a reason, which I'll show in a minute here. And each of these keys here, notice that I have a few different keys. I have VM is created, VM is running, can be found by name, so DNS resolution works. It's pingable, and finally it has remoting available. I've kind of chosen these at will here. This is the dependencies that I've defined that have to be in place before my actual test run. Because if these are not in place at all, my tests are going to be inconclusive. Sure, it could be read, but I don't know if it was read because it just couldn't connect to the VM, or the VM wasn't pingable, remoting wasn't available. I need some kind of smart way to manage this stuff. So this is how I have dependencies. I have these in order because these are ordered from lowest on the network stack all the way to highest. So if, for example, if PS remoting is obviously not going to be available if the VM is not created, if it's not running, if it's not pingable, that sort of thing. I guess you could argue ICMP stuff with pingable, but this is ordered from lowest to highest in the OSI model for our network guys. So I first check to make sure the VM is created. So in each of these keys here, I have 3 different script blocks. I love script blocks in PowerShell. They're just a real quick way to pass around executable code. So notice here I have VM is created and I have 3 different script blocks: check, remediation, and remove action. I'm going to loop through each of these dependencies in ordered value, and then it's going to run this check action. So notice here that I have inside of here, I'm just doing get VM, whatever I expect the VM name. If it returns anything, so it's created, it's going to return true, else false. So the check action script block always returns either true or false, 1 or 0. That's what we're looking for throughout this whole process, working or non-working. Whenever it goes through this, if it's true, it'll just continue on and say, yeah, the VM has already been created. That's great. Okay, but if it's not, and then depending on, which I'll show you here in a minute, the value of what we want to do, we can have the option to create a new VM and do it however we want. In this instance, I don't have anything in here because I haven't created a remediation code, but we have the foundation just to plug in whatever we want in this action. And then finally, if we did do any remediation action, so if we did change anything with the environment whatsoever, we can then run a remove action to just back out all that stuff we did before. So in this instance, maybe in the remediation action, maybe I created a snapshot or reverted a snapshot or something like that. Here, I can just restore the snapshot exactly how we could before. So the remediation action is a good thing for that. And then this is just this action, these keys and script blocks are just repeated throughout here in ordered action. So if the VM is created, okay, then we're going to check, is the VM running? In the check action script block, true or false? Yes or no. If not, here I actually have a remediation action. I'm going to bring up the VM before I even run the test. So it's going to wait, bring up the VM so I can have an accurate representation of what is working or what is not working. And then because in this instance, the remediation action is bringing up the VM and it was stopped before I ran my tests, here I will just stop it again. So leaving no traces of what we did whatsoever. And then the same thing, I'm just going to follow here. Can be found by name, VM is pingable, has remoting available. These script blocks are all going to be different things, but you kind of get the point there. You just can pick and choose, plug in whatever you want here in these in this dependencies array here. And then next here, this is where this doesn't make any sense at the moment. We'll see this. I have some right host commands just giving some references on where it is in this process. So it's going to start the dependency check. Here's where I have a dependency failure action. So maybe I don't want to actually go through the process of remediating all this stuff all the time. You know, it could take forever to actually build an entire environment. Here, I will just go into say, if it fails, just exit. Throw me a friendly error message and tell me what's going on with that. All right, here's where I'm actually going to be looping through all those dependencies. So here I'm just saying, checking whatever dependency. Here I am running the check action, so I'm invoking that script block, and then running that. It's going to always return true or false. If it's exit, so if I chose to not remediate anything, it's just going to say the dependency, whatever the dependency is, failed, halting test. You know, it's going to give me, instead of just saying RPC unavailable or something like that, it makes no sense. It's going to give you some useful error messages why that dependency failed. And then next, it's going to say, if we didn't have the dependency error failure action to exit, maybe we set it to something else, like go ahead and build it, I don't care. It's going to say failed, but hold on, I'm remediating it. It's going to go through and execute that remove action that we wanted it to. So here that I'm saying remove, this is where I'm actually executing it. This 119 here, this line, I'm actually I'm recording everything that I'm doing as I'm removing it, because if you do more than one of these actions can then build up, and you'll have to, because I need to figure out what I did to back all that stuff out after the tests are made. And then if it didn't, dependency pass, yay, end dependency check. I'm not going to run this. This is a snippet of code, which we're going to discuss here and go over the whole thing in a minute here. Okay, so after all of that stuff is done, notice that we haven't even written a single Pester test yet. This is why I keep going on and don't get focused on just Pester. If you know how to build these infrastructure tests ahead of time, You can put it in Pester. You can put it in, I don't know, Cerber spec or RSpec or Gherkin or whatever kind of test framework you want. If you have all this data built in a specific way, you can make it happen. But for Pester test, I go through two different or a few different activities here. Build the test framework, which is, you saw earlier that I essentially create one or more describe blocks, define the it blocks. It should have this title, it should do this, it should do this, it should do this, without even worrying about building anything in there. Next, I insert that dependency code, which you just saw, where I account for all the dependencies. And then finally, we actually do the read code. Once we know what we want, once we know all the dependencies are made, then we do the read code, which is essentially just a bunch of Git commands to do what we want. All right, so here are the actual Pester tests. And this example, it's not too advanced on purpose, because the whole focus of this is not showing how to use Pester, but how to build infrastructure tests. Just happen to use Pester under a context. So this will be run last after all of our DSC configuration has been ran. And this really is the easy part, because this is not a whole lot of code. Once you know Pester, this is a piece of cake. So in this instance, I've created a single describe block and say new in test environment. So maybe this is going to be a domain for a new test environment. I'm going to say, did it create the expected forest? I have forest down here, and you'll see I run get AD forest on the next. I'll show you the whole thing here in a minute. But basically, this is just grabbing whatever we need, writing the test, and just comparing them what we expect. Here we have expected attributes. Notice the non-known data, pulling that directly from DSC. Same thing here, creates all the expected groups. I'm defining that by, are the counts equal? Creates all expected AD OUs, same sort of principle. Creates all expected AD users here. Same thing. Here the users are a little bit different because I want to test those different attributes. In this instance here, I'm just looping through all the expected users, which I got from the DSC configuration, then just saying, okay, it should not be null or empty, so I should have had a match. The given name's right, the surname's right, the department, the distinguished name, and this is just a bunch of should be, etc. So this is the easy part. Pester tests are definitely the easy part to create. Once you know what you're looking for, and once you know the framework, once you've kind of built all this stuff out, the Pester tests are trivial. Really, if you know Pester at all, these are trivial tests. I don't have any crazy mocking or anything like that. We could talk about that forever, but for now, I don't have any of this stuff. These tests are very easy. All right, next, let's go over the whole thing here. So I've been building up to everything that's been going on. So, I forgot the cleanup here. We're not going to be doing the cleanup, so I'm going to skip over that for now. So here is where we're putting it all together. So to make things easier, I have this all in a single file, but you're probably going to want to separate this out. I just have a single script here, just called new test environment.test.ps1. And you'll notice right off the bat that this doesn't look like a typical Pester test, because it's not. Because this is an infrastructure test. This isn't a unit test. So here, this is a script that I built that has various parameters to it that you can call based on the environment that you're wanting to call it from. So, for example, this Pester test has two parameters, full and dependency failure action. You can choose whatever you want here to make design this test however you want, but in this instance, full I have a difference between basic and full set of tests. So maybe there's some anal tests that you want to run that are everything. I define those as full. I can switch that on and off here. Same thing with dependency failure action. In this instance, I have it exit, but notice that I can also do it as build too. So if one of my dependencies failed, now setting it as is, it's just going to go ahead and exit out. If I set it to build, it'll just go ahead and build that infrastructure up, build all those dependencies, and then run the test afterwards. And then here is where I'm actually reading all that stuff in. A lot of this code is going to be the same as what we talked about, so I'm not going to go over it. I wanted to show you where this fits into the the grand scheme here. So I'm grabbing all this expectation, and here I'm saying if full is present, that's when I actually do the dependency checking. If you know for a fact that all those dependencies are there, then you don't even have to use full. You can skip over all this dependency checking if you want. But if you want to be completely sure, it depends on how anal you want to get with this, you can do all these dependency checks. And these dependency checks are exactly like we just went over, so I'm not going to go over the code. I'll show you where this fits in. So that's where the dependencies fit in. I'm going to start the dependency check. This is exactly the same code. I'm going to go through, check each of those, check, and remediate. If not, here's where I can say, here's that parameter, dependency failure action equals exit. If I exit, it's just going to throw a dependency, halting, good to go, you're done. If not, it's going to say failed, hold on, we're going to remediate that. All right, here's where you would actually do the code execution. So here, I'm just going to invoke the DSC configuration. I defined what we want up top, the expected stuff, checking for dependencies. Here's where I actually invoke the code. I'll actually run through the DSC configuration, build the VM, or not build a VM, create the domain, create the users, objects, and all this stuff. Then, finally, once all that's done, then I will create my Pester test. Now, you may notice, if you're familiar with build or release pipeline, this is kind of like a little pipeline all-in-one script. I was meant to do this in all-in-one script. If you're, in a few weeks, I'm hoping that the Pester Microsoft Virtual Academy course is out. I'll go through an actual build pipeline, this whole similar process. We start with source. We do the build, which is essentially just going to run DSC in this instance. We're going to run the test and deploy. So it's kind of similar to a build situation. So for our Pester test, we first do our arrange and act phase, which means just gather up whatever we want before we do any of those assertions ahead of time. We're going to do a PowerShell remoting session here. That way we can query it over and over again. We're going to grab the forest of what it is after the DSC configuration ran, the groups, the OUs, the users, grab all that stuff ahead of time, and then we just can simply compare it to expected. Creates the forest, creates the users. You've seen these tests before. I'm not going to go over them, so it creates all this. And then finally here, in the after all block, if you're not familiar with the after all block in Pester, it will run after all those it blocks run. Here, I can say if I actually did any kind of remediation, if I made any kind of changes just to perform my tests, here is where I will grab all these remove actions and then run through all of the teardown actions. So here I'm just saying run the remove action. So this is essentially looking up here in the dependencies. Where is it at here? Go over here to dependencies. This removal is actually, wait for it, let's remediation action here. So notice that it's right here. I'm just doing plus equals here to add that index to the array. I'm keeping track of what happens here. So in the main process that I'm doing, I know this already since I kept all that in an array. I can just reference this after all my tests run, and then if there was any remove action, if we did anything, I can just run the remove actions and tear it all down and go from there. So that is the whole process in each of those for the whole demonstration. All right, so now let's just run this and see what it does. So I'm going to run it with invoke Pester, so I'm just providing a path to it. And here I'm just going to run the default set of tests, and I'll show you what that looks like. So notice there that it says beginning code execution in the terminal, and it's just going to go through the typical DSC stuff, yada, yada, yada. Okay, then as soon as the DSC done, then we're going to say in code execution and know where that is. Then it's going to run your Pester test, and then if we had any kind of teardown activities, it would be here and between begin and end teardown. So this is kind of like a build. Really, this is like an actual software build inside of one single script here. All right, so next thing is we invoke the full test suite of test, but just exit out. So it's kind of a funky way to pass parameters to a Pester script, but you can just do the, with invoke Pester, you can do the script parameter here, and then pass it a hash table with a parameters key in it, and then another hash table with whatever parameters you want to pass. So this is basically just saying full, going up here, passing full to scrolling, passing full to right here inside of that script. And same thing for a dependency failure action here. All right, so I'm just going to run this and then see what the behavior is. So notice now I'm doing a start dependency check. I'm checking if the VM is created. Is it running? Is it found by name? Is it pingable? All these dependencies ahead of time. Then I run the DSC configuration to make it happen. Once all the DSC configuration is done, run the Pester test. Works great, blah, blah, blah. This could be perfect in a build situation to where if you make a change to your DSC configuration and your build agent then kicks off, it's going to kick off, the DSC configuration is going to kick off your test, all this stuff automatically. That's the key. And then finally, we can do dependency checks, and we can do dependency failure actions of build. So in this instance, if a dependency fails, we can just automatically execute some kind of code ahead of time, and in this instance, it would be build. Notice that we didn't do anything here because there was no dependencies that failed, but we did run the Pester test ahead of time here, and it says no dependencies built, thus no teardown necessary. So we get some output of what's going on here. Okay, so let's mimic a failure. So I'm going to stop the VM that I'm targeting first. Wait for it. Wait for it. Okay, the VM, the test lab DC VM is down now. Now I could just invoke that default set of tests, but I'm not going to do it because it's going to fail miserably and it's just going to blow up. And you'll go ahead. I'll show you the link to these demo resources at the end, but trust me, it blows up. Now I'm going to run the full test. I'm going to do the dependencies again. So it's going to check the dependency. Is the VM created? Let's check and see if that. Yes. Okay. Is the VM running? No. Halting test. It's not going to run any of the tests because no dependencies were met. So you can see here in red here that we have the dependency VM is running failed halting tests because we don't want to actually run any tests because those dependencies weren't there. Next, then we'll just build this, correct these dependencies on the fly by doing full for the dependencies and the failure action of build. Notice now that it's saying the dependency failed, but hold on, I'm remediating this. In this instance, it's just bringing up the VM ahead of time. So it's bringing it up, waiting for it until it's pingable. And then here, it's probably going to fail in this remoting one because I didn't put enough timer in here to actually make this happen. So the VM just came up, and sometimes this will fail here. Yes. So let me just run this again just to make sure I'm not crazy. So now it's up, dependency pass, VM remoting pass available. Great, it's all good in the hood. So then finally, what we would have if we would have changed anything, we can now put it in the state where we left it. I put it in here because the VM is on, but we did turn it off over there. So that is the demo. So that is just about the majority of the talk. So now this is kind of the first time I actually did anything with this with YouTube Live, but here is the demo resources that you can get from my GitHub repo where I have all this code available for you, bit.ly/infra testing. And then I'm going to give a few minutes to for any questions in the comments that any of you guys have. You can either ask them now or ask them later on Twitter or email or whatever. I'm available wherever. So I will just wait a few minutes here. I know there's a delay on the IM. I'm giving you at the count of the easy button. That's when I'm going. 3, 2, 1. All right, moving on. Hit me up whenever. I'm not going to waste anybody's time with the demos, but that's it. So I really appreciate you guys coming along, and it looks like I did do it in just about an hour. I appreciate everybody that watched live, and I appreciate everybody that's going to watch this on recording. I will make this available. This will be recorded, so this will be available on my channel, and I really appreciate you guys joining in. See you later.